Hi everyone, welcome back to my channel. Here's another optimization problem. In this question, I have a ship that's sailing due north at 6 kilometers an hour, and it sights another ship, which we call it ship B, and it's due northwest 4 kilometers away from ship B. So that's where ship B is located related to ship A, 4 kilometers away northwest, and it's sailing east 5 kilometers an hour. How close will they pass? So this is a little bit different than all the other questions that are posted online, so pay close attention, and we're gonna figure out how different this is. So if this is my ship A and it's going north here, this this vector is going to be representing the speed and the velocity of this ship for ship A, and ship B is going to be northwest. So if this is north and this is east and this is west and this is south, so this guy is going to be northwest, so it's going to be somewhere here, ship B. And let's maybe draw that in a different color and mention that from here to here it's 4 kilometers, and this is ship B, and it's actually east 5 kilometers an hour. So the velocity vector for B is going to be a little smaller, 1 unit smaller, and it's going to be 5 kilometers an hour. Now it says, how close will they pass? Now in order to do this, we need to continue and see what is the line that what is the point that these ships are going to meet. So they meet at this point, and let's say we're gonna assume that at some point here, for example, A is here and B is somewhere here, and that is the closest distance that they are. I'm gonna draw that in a different color. Let's do that in so I'm going to call that D, and that is the distance between A and B at, let's say, when they meet. This is at time T, and that's when they meet, and that's how far they are. And what we're trying to do is to minimize that distance and to kind of find out at what T this distance is the smallest. Therefore, write an equation for D, take the derivative, put it equal to 0, find the time, and then find the distance that A and B are closest together. Now, in order to do that, let's try to find out where this yellow point is exactly. In order to do that, what we need to do is to find out, if this is 4 kilometers, find out what this distance is and what this distance is. Therefore, we can find out where this yellow dot is and where they meet. So since this is 4 and this guy is northwest, and northwest means that this angle and this angle are 45 degrees and they're equal to each other, maybe we could just use some sine or cosine relation and trigs to kind of find out what that distance is. So if this is 4 and this is 5, so this side, let's call it the x, is going to be sine of 45, and this is y. So sine of 45 is equal to y over hypotenuse, which is 4, and cos of 45 is equal to x over 4. Now, if I were to calculate y from the first equation here, y is going to be 284. Now, since sine and cosine of 45 are equal to each other, that is also equal to x. So this distance here on my picture is 2.84 kilometers away, and so is this one. I can actually write a relationship for this one. So if I'm looking at this purple triangle here, and I'm trying to write a relationship between, so the purple y and the purple x here, I would need to write a relation for x and y here, and I can relate that to the speed of ship A and ship B. And how can I do that? Now at this point, this yellow point here, ship A would have traveled 2.84 2.84 kilometers minus the distance that the ship would travel at the time t. So at time t, you're going to be at that yellow dot. And since there's a relationship between velocity, distance, and time, and since I have the velocity and I have the time here, the distance that ship A has traveled is going to be v times t. And since the velocity of my ship A is 6 kilometers an hour, I'm going to have an equation for my dA equal to 6t. So the distance that the ship A has traveled from here to here is 6 times t. And the distance here, the purple distance here that I called y, is going to equal 2.84, which is the big distance from here to here, minus this distance, which is the big distance is 284, and the small distance is going to be 6t. Now I can say the same thing for ship B. So let's say if from here to here is 2.84, and at this time, as time t, ship B is at this blue point here, so the distance that ship B would travel from here to here is going to be 5 kilometers times t, and the distance from here to here is 284. So this x purple part here, which is the distance that ship B has traveled, is going to be equal to 2.84 minus the 5t. Okay, great. So now I have two relationships for my ships here. Now I need to find out and write an equation for D here. Well, obviously this is going to be a right angle triangle, so a relation for my D is just going to be equal to, I can use Pythagorean theory to write the square root of distance A, which is 2.83 minus 5t to the power of 2 plus 2.83 minus 60 to the power of 2. All right, now all I need to do that I have to minimize this distance by taking the derivative of it and putting it equal to 0. And that will help me find t, which is the time that these two are going to be at the minimum distance together. All right, let's go to the next page. If I take the derivative of what's inside or underneath the square root, that's pretty much my derivative. I don't need to take the derivative with the square root, because if what's underneath this square root is minimized, when you take this square root, it's still going to be minimized. Taking the square root of a minimum derivative, it won't really make a difference, so I can just focus on that. Now my d prime is going to be the derivative of the first guy here, so 2 times 2.83 minus 5t. Deduct 1 from the power, so 2 minus 1 is 1, and then take the derivative of what's inside. So the derivative of what's inside is derivative of 2.83 is 0, and the derivative of minus 5t is just negative 5, and then plus the derivative of the second part, which is 2 times 2.83 minus 60 to the power of 1, times the derivative of what's inside. The derivative of the first one is 0. The derivative of the second part is negative 6. All right, in order to kind of simplify that, I have a negative 10 here, so I'll multiply it by this. So I get negative 28.3, and the negative 10 times this would be a positive 50t. And then here I have a negative 12, and then I'm just going to expand that out here. A negative 12 times 2.83 is negative 33.96, and the negative 12 times negative 6t is positive 72t. Okay, now in order to clean this up a little bit, I have a 50t and a 72t here. That's 122t. And I have a negative 28 and a negative 33.96, which is negative 6226. Okay, so that is my derivative here. Now all I need to do is to put this equal to 0 and solve for t. So I will move this to the other side of the equation, and I will end up with 122t equals 62.26. Therefore, t is equal to 0.51. Well, we're solving in hours, so 0.51 hours. Okay, so now that we have t, the question was asking us how close will they pass. So they're looking for the distance here. Now, since d is equal to square root of x squared plus y squared, all I need to do is to find what dA and dB are, and then by substituting t in them. And then once I have that, I'm going to substitute that back into my d equation and find d. Now, let's do that. So dB is equal to 2.83 minus 5t. Now for t, I'm going to substitute 0.51. And that will give me 0.2784. And for dA, I will get 2.83 minus 6t, which is 6.0.51. That is equal to negative 0.23. So if we actually go back to my diagram here, my a value, so the distance a is going to be negative. So therefore, that means that I'm going to be actually past this point. So where these guys are actually going to meet, negative 2.3. So from here, from this point, ship A would be at 2.3, and B is going to be at 0.278. So it will be somewhere here. So that's actually where they're going to meet. So they're going to not meet where we assumed they were going to meet. They're going to pass this point. That's why we got a negative number here. Okay, now that I have this, finding d is easy. So all I need to do is to take the square root of this to the power of 2 plus 0.23 to the power of 2, and that will give me 0.36 kilometers. So they would be 0.36 kilometers apart, and that is the shortest distance that they're going to be relative to each other. That's about it. If you have any questions, please comment them down below. Make sure you subscribe and click the like button. Thank you.